we go. All right, guys, so the database we're going to be, well, really the platform we're going to be working with today is called BigQuery. It's made by Google. Basically, it is their way of implementing databases and everything. And hey, how's it going? So, by BigQuery, well, one, it's free, anybody can access it, it's online, really easy stuff. But two, this is a pretty popular platform for businesses at the moment because it can handle a much larger amount of data than most other cloud-based database services can. So it's definitely a good one to learn. It's in pretty high demand, so might as well take this as a first step. Right, so if you have your computers on you, great. If you don't, well, everything's going to be on our website. I have the link over there off to the side, and it'll be the first thing that you see on that tab. So don't worry if you can't execute everything on the fly right now, it will be there. Right, so let's just go ahead and get our account started. We can just go to, all you really have to do is look at BigQuery. It should be the first result. And it'll ask you to create an account up in the top corner. Just hit start free. If you're logged in with your Google account already, it'll be pretty straightforward. Just go ahead, create your account, all that stuff. Free continue. And it should not be, oh yeah, you can just hit start for free down there at the bottom. That should not be a problem. All right, so I might have to go and look up BigQuery Sandbox instead. Yeah, enable BigQuery Sandbox. So Sandbox is the free version of BigQuery. So yeah, let's just go up here. We'll ask for authentication, a couple of things, create a project, blah, 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 okay. Let's just open this up in a new tab and follow along. Okay, so let's pull this up off to the side. So if you look at BigQuery Sandbox, this enable the BigQuery Sandbox should be the first thing that pops up for you. If you go to that and then hit go to BigQuery, if you're already logged into your Google account, it should launch BigQuery straight away for you, and you should be able to access everything. Is anybody having trouble getting to this point? Getting into BigQuery?
Just give us 1 second.
Okay.
So it says go to BigQuery, click on that.
Yeah. So I just looked at BigQuery Sandbox. It should be the first one, and then it says go to BigQuery. So let me see what's going on here.
It's here.
And you're already logged in, so you might have to click create a project. Oh, it's right over here. That should work for you. It probably doesn't like the underscores. Okay, looks like you're in. Is everybody else able to see this screen up here? BigQuery Studio, all that? Okay, cool. So basically, this is an area where you can write queries and access publicly available data sets and databases that BigQuery and Google have just kind of loaded into their platform for anybody to access. So if we go in and well, the database we're going to be using is called The Look, and I will try and see if I can find that in here. If not, no worries. We can just query it directly and see what's going on.
Quick note, are we recording this session?
Yes.
Okay.
So, yeah, let's just access this directly. So if we go up here, next to untitled query, hit SQL query. This will open up an environment for us to start writing SQL queries. So SQL queries are basically ways for you to write code that either pulls data from the database that you want to see or allows you to create tables and other things inside the database, right? What we're going to focus on right now is just how to access data in the database. We'll touch a little bit about how they work as well, and might get into how to create tables and things, but we're probably just going to stick to accessing for tonight. So from here, we're going to write a very basic SQL query. And of course, you have to be careful about spelling and all that, but otherwise, this will be pretty straightforward. So I'm going to write select asterisk, and let me zoom in here so that's a little bit easier to see. And from, be very careful about writing this out, and I highly suggest that you copy and paste this going forward, because it's long. This is going to say BigQuery, no spaces, dash public, dash data, period, the look, no spaces, underscore, e-commerce, dot, users. And finally, a semicolon at the end. So I'm going to execute this, and then we'll get into what the code's actually doing. So I run this, and it's going to pull up a table right down here at the bottom in the results tab. So what did this query actually do? Well, select basically means that it's going to grab whatever columns you specify. And from is the table that it's going to pull the data from. So basically, if you think of databases as consisting of a ton of much smaller tables and data sets that all connect to each other in some way. In this case, we're just referring to a single table and saying, I want to get all of the columns present in that table. And that's indicated by that asterisk. The asterisk basically just means grab everything, right? So yeah, that's BigQuery dash public dash data period the look underscore e-commerce dot users. Can everybody read that okay?
Yeah.
Okay. And again, these queries are going to be on our website and everything, so you can always copy paste that, go back into BigQuery, execute them yourself, play around, do whatever you want. So yeah, that's the most basic query that you will probably ever perform. And it's good for like doing a data preview and things like that. What's up?
While I'm aware of the syntax, so this table, the look e-commerce, it is stored somewhere on the Google Cloud.
Yes.
And we are retrieving information from that table.
Exactly.
Okay.
And if you want to get deeper into the syntax of in this from statement, basically it's saying, hey, this is the larger area that I want you to pull from, and then delimit with a period to look specifically at the look e-commerce database, and then delimit further to the actual table that you want to see. So basically, it's just subsets of things that exist in BigQuery. And you'll also see this kind of syntax in Snowflake and probably in other large database environments that have multiple databases inside them.
So we can also like change the value of like whatever there is on the asterisk, like retrieve maybe like less amount of columns.
Yes, you can definitely retrieve fewer columns, and that's what we're going to get into next. So what we can do is say, I only want to see the first names and last names of all of our customers. And if we want to do that, we can just go down and say, select first name, last name. And I'm just going to copy and paste this users, because again, that's going to be really annoying to type out every time. And you'll notice that I have this semicolon here. Why do we have a semicolon? Basically, that is a way for SQL to understand that these are different statements. You can execute just this without the semicolon, but if you were to add a second query underneath it, it's going to think that those two queries are part of the same query and get very confused, because it's basically thinking, oh, there's two select statements and two froms, like they're not related to each other in any way. How do I execute this? So that's why we use those semicolons to delimit if we're doing multiple queries in the same file. Yeah.
So I see that space in the third column. Is that necessary?
The space in the third? No, you don't need that. Yeah, that's just for formatting. And SQL is actually pretty flexible with formatting. Like for instance, I could say just tab first name and last names onto new lines, like this. And it'll execute just the same. So if I select all this and hit run, I just get the first name and last name from that table. Because SQL, like I said, is really flexible in formatting. That can be all in one line. It can be like this. It can be something far less readable if you wanted to for whatever reason. But hey, this works. But yeah, if you want to get columns, specific columns, really, you can just call upon the exact names of the column in the table that you're referencing. More tables, which we'll get into later. And let's say that we don't like the formatting of these column names. Let's say, oh, those underscores, those are ugly, let's just replace those with spaces, right? What you can do instead is use pretty much the same syntax, but what we're gonna do is add a statement as, and then do a backtick, two backticks actually. And between the backticks, you're gonna write whatever you want your column to be named. So in this case, I can just say first name like that, and then add our comma at the end. And I can do the same thing for last name. Just like that. And whenever I do that, that's going to allow us to effectively rename those columns in our results. So if I hit up to run, you see now it says first name, last name instead of the weird underscore lowercase thing. Yep.
Would it be safe to say that as Colab is to Python, BigQuery is to SQL? Like a
No, because
cloud
BigQuery is an actual product that companies will use to store their data on.
okay,
Colab's just like a public environment that anybody can run Python on. No
Right.
company is probably going to be using that as their main source to run Python.
right, but I mean, this is basically a web application for essentially SQL.
Yeah, I mean, that's true.
Yeah, and so,
Yeah, and Snowflake will operate in a similar manner too. A lot of cloud database environments are going to do the same thing.
okay.
But yeah, these are actual products that get used by, well, real companies. And now we know how to pull specific columns. We know how to pull all columns. Great, we got a good start here. But let's say we only need a small amount of information at a time. We know we need to filter the data down to something. So for instance here, let's say we're concerned only with organic web traffic. Who found this website through an organic means, basically? What we can do is add a new clause under the from statement. So let me copy and paste this. And what we're gonna do is add here at the bottom, where, and then we'll refer to the column that we want to filter by. In this case, we can say traffic source and equals single quotation marks organic. And using that, that's going to limit our number of rows that we get to just users that were of organic traffic. And you'll see that whenever I run this and compare it to the results here. You see here we have probably over 100,000 users being represented. Now, a lot of those are probably going to be duplicated, that's fine, but for now, let's just look at that number. And this represents every traffic source. But if I run this, that number became quite a bit smaller. Now it's about 15K, so it's literally only people that got here through organic web traffic. Right. Now, this can be useful. It can be useful to get all of these, just a huge amount of data at once. Say that you have a bunch of data that you need to pull for like a Power BI or a Power BI dashboard, or if you're going to be performing some deeper analysis on it or something, you can just get what is effectively a spreadsheet of all the data that you need by using a query. Or you can use SQL to write basically reports for you. So let's say, for instance, that we need to know the number of users that we have in the database, right? How many people have actually bought a product from the look? What we can do then is use an aggregate function. In this case, we're going to use count. So let's say select count. And in this instance, let's see the number of people that got here through organic traffic. So let's say count traffic source. And then we can just write our from and where again. And whenever we run this, it's just going to produce a number at the end. Right, that's the same number that we saw before. That's the number of organic web traffic users that we have. But again, this is really not all that readable. What does F0 underscore mean? Basically nothing. You can just rename that again if you want to. Otherwise, it's there. Some platforms will produce a meaningful name. BigQuery doesn't. But for now,
Traffic source is one of the column names?
yes.
Okay.
Right. So now we have an idea how to count some things. There are other aggregate functions, like you can get the largest value by using the max function. You can get the average value by using, well, the average function and stuff like that. There are plenty of other things that you can't use. It's just count's the easiest one to look at here. So let's say that we need to filter our data even more than we already have. We know that we're interested in organic traffic users, but what about those that are under the age of 30? How well are we doing in that demographic, right? What we can do is just add an extra clause to our where statement. So let's copy this and write it down here. And what we're going to do is just write and now we're going to refer to the age column. So age is less than 30. And whenever we run this, it's going to reduce our result set even more, naturally, because now it's looking for cases where the traffic source is organic and the user was under the age of 30. You can also use an OR statement, which would basically say, oh, if the traffic was organic or the user was under the age of 30, then produce that as a valid result. But and is generally pretty common. As you see, the number reduced even further to about 4.5 thousand. Right. So this can be useful information, but what we've done is just look at one traffic source at a time or look at the entire database at a time. What if we need to see the number of individuals per traffic source? We can do that just in one large query. We don't have to run several where we say, oh, traffic source is organic, traffic source is something else or something else, right? You don't have to run multiple. What you can do instead is run something called a group by statement. And it'll become clear what that does whenever we actually execute the code. So let's say select traffic source. And we're going to say count. Counts the traffic source. And again, we're going to say from. And now, we don't need to use any group by statement because we're just looking at the number of users per each traffic source. We don't really care how old they are or anything like that. There's nothing additional that we need. What we do now is write group by traffic source. And what traffic source is going to do is basically say, hey, we have so many different unique entries for traffic source, say organic, say web, or any of these other things, right? And it's basically going to look at each of those values as a distinct group, right? So it'll separate out your organic traffic from anything else and say, now in each of those groups, count how many people are in those groups. And whenever we execute that, we see that we now have the number of folks in each traffic source. Great. That can kind of help us to understand where people are coming from in a more easily understandable way. Great. Now, this is all fine and good. It looks like everything is ordered where you have your largest source at the top, and then smaller ones at the bottom, and all that. Cool. That's fine and all. But sometimes you're not going to get that. And sometimes you might want to order your data where, say, the smallest value is on top. So let's figure out how to do that second part first. How can we say, I want display to be the top value, and then just get larger as you go down?
Sort.
Yes, you're going to sort it. And that's going to be done with a clause called order by. So we can say order by counts traffic source. And you'll see whenever we execute this, that now our smallest value is at the top. Cool. And if I wanted to make sure that the largest value is at the top, I can run pretty much the same query except I'm going to add something else to help clarify that. I'm going to write descending, except it's just abbreviated to DESC. That'll just ensure that it's going to go from largest to smallest. And the reason why you might want to use this descending or ascending, even if your initial query provides it in the order that you want to see it, is because these databases aren't really as linear as I made them sound earlier. You know how a database has a very set order where you have row 1, then row 2, then row 3, and that really doesn't change? That's not really true for a database. It doesn't really matter the order that the rows are in, it just considers that as a mass of data that it has, right? So in theory, if I were to run this without an order by statement, it could produce it in any order it wanted to. It would just say, hey, you got your results, be happy with it, pretty much. Right, so we got through group by and order by, descending, all that. Now, this is all helpful. This has shown us how to get things from a single table. But as I mentioned earlier, there are multiple tables in a database. But before we get into how to access multiple tables, let's talk a little bit about why we have multiple tables and how they actually relate to one another. So imagine that you have one giant database and say you have all of your, or a giant table rather, and you have like, oh, here is the quantity of the order, here is the first name of the person, the last name, their address, all this stuff, and you have the order ID and all that. Let's say that a person makes a single order, right? If they only make one order, we know that this information, it's not going to change, right? That's never going to falter. But let's say that this person makes a second order, right? Now, if you don't have, in this scenario, you basically have to put the person's information in there twice, right? Now, let's say that this person moves, their address changes, or they get married, their last name changes. Now, if you have to update that person's information, you have to do it in both rows. And you can imagine that in a massive data set, that would be an absolute pain to manage. And that wouldn't just be first names and last names. That might be like a distributor's basic information, stuff like that. You can have a huge amount of information that you have to track and make sure that it stays consistent over time. So what you can do instead is say, okay, instead of having just this one table, I can have two tables. I can have one that's just for the customer information, and one that is just for order information. Now, you can just store whatever information you need on your customer, first name, last name, address, here, and then have a column that just represents them through an ID. And you can have your order information that has, say, your order ID and your customer ID. Now, the only place that you have to update customer information is here. Your customer is only represented once. That means you only have to change it in one place. And now all that information is also represented in the order table through the ID that's associated with it. And these are going to be referred to as a primary key, which I'll denote by saying PK. And in here, it's going to be denoted by foreign key, FK. Basically, a primary key is a column that has entirely unique values that represents each row in the data set. Every one of these is going to be unique. It is uniquely associated with one entity in that table. Now, if we pull this ID into another table to help represent this entity, in this table, it becomes a foreign key. Basically, it's a primary key in another table, but it's being drawn in here to provide extra information. And so, basically, a database is structured like this to, like I said earlier, control for cases where you have to update data multiple times. And it also just makes things a little bit easier to manage in general, instead of saying having one giant table that you have to make sure is pristine 100% of the time. You can just look at these much smaller, much easier to manage tables and just deal with those as things pop up, basically. And so with that in mind, we can use something called a join in order to call upon two or more tables at once. So say, we know that we have users and we know that we have orders. How do I see the order, how do we see the customer associated with an order? Well, let's get into that. So we can now say select. And for now, I'm just going to use the wildcard, that asterisk, but we're going to replace this later. And we're going to say from. I'm going to tab this out so it's a little easier to read. You don't have to do this, but it should make things a little easier to read. And now we're going to call upon the users table. And we're just going to call this orders. And now we're going to join a new table. So let's copy this bit here. And now we are concerned with the orders table, the users table. So we can say dot, wait.
You want orders up at the top?
Yeah, this should be users, sorry. Users and then orders as orders. And now we have to clarify the column that we want to refer to when we're joining them together. What's our foreign key? What's our primary key? And we can do that by just saying on orders.user ID equals users.id. Basically, that's just saying, hey, in the orders table, look at user ID. That is the same as the column ID in the users table. So now you can pull in all the information that you need from both tables. If I were to run this as is, it's going to provide all of the order information and all the user information at once, which might not be something that we want. We might just want to see, say, per person and per order ID, what is the status? Was it canceled? Is it going to progress? What's happening to it? Has it been delivered? All that stuff. And we can now just say orders.id as order ID. And we can refer now to our first name, last name, and a couple other things. And finally, let's grab the status. And whenever we run this, so you see that we don't have a proper ID here. So it might be order ID. And there we go. Now we have the ID for the order, the first name, the last name, and if the order was shipped, if it's been canceled, whatever the status is, right? Cool, that's easy enough. And we know that there are gonna be multiple orders per person, which is why we pulled in the order ID. Basically, this helps us see exactly what we're looking at. Cool. Now, that's easy enough. We know how to, say, pull together two tables and get information. What if we need to pull together more than two tables? What if we need to see the order ID, the first name, the last name, the name of the product, and the status of the order? What if we're interested in all of these things, right? We can use basically this exact same query, but we're gonna add a little bit more to it. So we have the order ID, first name, last name, status. Last thing I'm going to pull in is the name of the product. So let's call that name. And now we have to call on another table. Join. And let's copy all this. And then say that we are referring to the products table. Call that products. And then on orders.product ID equals products.id. So you basically just have to use two join statements to get these things. I have to call on order items and not orders, so I'll correct that now. And we go to our results. Now we see order ID, first name, last name associated with the order, the status, and the name of the product associated with the order, or products associated with the order. Which can be useful information, might not be the most, but hey, it's there. And of course, you can use these joins with more complex queries. Like you can incorporate a where statement into this and order by and all these other things. And for a quick example of that, let's go through and find the returns by product name. So let's say select name, count, status, as returns, and from, we're going to look at order items again. So from order items as, and let's just call this orders again for simplicity, and we're going to join the products table again.
I'm getting an error. Doesn't run.
Okay, I'll take a look at it in a second. Let me just finish writing this. And join edits here. Cool. And now we can just say where the status is return. And now we can group by the name of the product, and finally order by returns, and let's make it descending. So this is going to show us the number of returns per product. And when we run that, we see, hey, there is something going on with this scarf. It has relatively large amounts of returns, or this tech training, whatever. Yeah, 6 returns. In the grand scheme of things, 6 returns probably isn't that big a deal, but this might be for like a month or something like that. It could be a very small amount of data, which means that might be a more concerning value. All right, and let me take a look at what you got going on over there, Rupa. All right, what's up?
It says there's a syntax error.
Oh, it's probably because you have the quotation marks around it already. Where you said as quotation already.
Oh. New product ID not found inside orders.
Oh, it needs to be order items instead of orders.
Order items, that's the name of the table.
No, I mean up here, where you're called on the actual table, it needs to be instead of dot orders right there, order underscore items. I'll come back in a second, but make sure those are named the same thing. Which ones? What's going on?
I'm getting a syntax error also.
Yeah, so you don't use single quotation marks in order to use different names. You use a backtick, so it's going to be up here. That's Yeah. Yeah, and different varieties of SQL are going to do different things. Some of them will take backticks, some of them will do what you're trying to do, but this one uses backticks. Is that? Oh, because you have a semicolon there. Yeah, it's going to try to read everything above that as semicolon, everything below it, it's going to get confused. All right. Yeah.
Just for clarification, you put the as orders and as products, so you don't have to type all that stuff out when you,
Exactly.
it's an alias.
Exactly, and you can shorten that even further if you want to. I just needed that so it's a little easier to see.
Right.
But this could be as few as a single character. It's just an alias that we're using to refer to.
So when you
the
say
entire
orders dot product, you don't have to type BigQuery.
Exactly. Right.
So,
I could easily just change that to ORD or O.
So in such a case,
whatever.
it will be on ORD dot product ID.
Yeah, you still have to type out the whole column name, but you can shorten down the table name. And now, this is cool and all, but here we're showing all 13,000 products that exist. That can be useful information, but what if we only need to see, say, the top 10 most returned products? We can do that by adding a simple clause at the end of our query, and that's going to be limit. Limit 10. Basically, that just says limit to the first 10 rows.
like a header.
Yeah. And if we run that, cool, we only have 10 rows. Those are our top 10 most returned products. Easy enough. And that's useful, but now let's say, okay, we know we're top 10, but that cuts off at around 5. What if I need to see all products that have been returned 5 times or more? right? Because we know that that's the lower cutoff, we might have more products that were returned 5 times, but those are probably the most interesting to us. So instead of using limit, we can use a new statement. This is going to work very similarly to where, but it is different. And you'll see that under group by, you're going to have a new statement called having. And now we're just going to say having count status is greater than or equal to 5. The difference between having and where is that where is going to look at the entire data set that you're pulling from, whereas having is just going to look at the groups that are produced by the group by statements. So remember how here we're looking at the number of times that a product has been returned in that group by statement? This is just going to say, okay, we have this product, it's been returned 5 times, cool, show it. If it occurs less than that, then you don't show it. It's not looking at the data itself, it is looking at the results of everything above it. It's looking at the results of that group by statement and then using that as a way to filter down your results. So if I were to run this now, you'll see that we no longer get 10. Instead, we get 41 because that's how many products that we have that will return greater than or equal to 5 times. Cool. Again, can be useful information. And now, another thing we can see is in place of an and statement, we can use an or statement as I referred to earlier. So or statements are pretty much just saying, hey, if this is true or this is true, then consider that as part of the filter. And both can be true and it'll still be included. It just has to be that one of those statements is true in some fashion. So let's say that we're interested in orders that were either returned or canceled for whatever reason. Then we can use this query up here and say where status equals return or status equals canceled. Now, usually if you have multiple where clauses, it is best to add some parentheses around them just to make it so that SQL doesn't get anything confused and to make it a bit more readable for whoever is looking at your code. And if we execute this one, we will see everything that was either returned or canceled. Great. Easy enough. And another way we can write this is if you're referring to the same column in a where statement, you can use like instead.
Why did the data change? Like, I know that in the previous data that I saw, the number of returns that we had was like 6 at max, but the moment we used or it went up and reached like 19, I guess.
Mm-hmm.
Why did that happen? Because like they did add, the cancellations as well in the return column, or did it?
Yes. So what this is doing now is, we're looking at this one here. Well, for one, this doesn't have any having statement, so it's not considering that at all. But now it is counting both instances where the status is returned or if the status is canceled. So the numbers are naturally going to increase because of that. Now, if we are trying to do an OR statement within the same column, then we can use a different statement called in. So we can say status in. And now we're just going to refer to the list of values that we're interested in. So we had canceled and return. And this is going to produce the same results. I mean, maybe minus the order of things like I talked about earlier, but it'll produce the same thing. So OR is generally useful if you have really complex logic that refers to multiple columns, whereas in is good if you're just referring to a single column or if it's a smaller part of a larger where clause. And as we look at this, cool. We now have our values. Great. And of course, you can create some pretty complex queries. But one thing I want to discuss are the different types of calculations you can do in SQL, because there are quite a few data types that you'll see in SQL and in databases more generally. And each of those are going to be handled a little differently. So your main data types are going to be of character, of numeric, and of date. Now there are smaller subsets of each of these, but these are the three general categories. Character is basically going to be something that is neither a number nor a date. I mean, very general, but basically you can think of this as like somebody's name or a product code or something like that. Something that you can't do math with and something that isn't a date. It's just kind of its own weird little thing. Numeric is pretty much exactly what it sounds like. It is a number, you can do math with it. And a date, what it sounds like, a date. Now there are also things like timestamps, which get further into like hours and seconds and things like that. But just for simplicity, you have these. And each one is going to work a little bit differently, depending on the kind of math you need to do with them. So say, oh, with numbers, I can do pretty basic addition, like with all the symbols you'd expect. You can do a literal addition with this, or you can use sum like that, add in whatever you need to sum together, all that stuff, pretty easy. But date isn't going to have that. Date has its own function. Dates will have stuff like date add. And then you have to add two dates together and however you want to do that addition, say in days or in hours or something like that. And a character, you can't really do addition, but you can move multiple things into the same column, and that would be concatenate. I'm just going to shorten that down to concat. Basically, if you have like a column that says A, one that says B, one that says C, you can concatenate them to get one string that just says ABC, right? So all that is pretty useful information over there, but that's something that we don't quite have time to get into now. Like I said, SQL can also be used to create the database. You can save the results of a query as a table that other people can call on. That would be called either a table or a view, one of those two. And there are also things like CTEs, which basically let you define a table without saving it to the database, which can be really useful because if you're just making a bunch of tables that you refer to later, you're going to annoy everybody if you just clog up the database with irrelevant tables, right? nobody wants to manage the query that you use one time for one project, right? But yeah, that is basically what I have to cover for tonight. As I said, the queries are gonna be online. All right, what's it?
A view you cannot operate on and a table you can, if you save it as, are you gonna send it to somebody or what? Is that the?
No, you can materialize a query result into a table. You can do that.
Right,
That allows other people to get access to it.
right,
But you can also create temporary tables, which will basically only exist for the duration of your query. Or you can use something called a CTE, which basically does the same thing.
right, with the view, if you wanna just send.
Yeah.
Is that a non-operable representation of the?
So a view is pretty much what you're saying. It is literally just the result. You can't do anything with it.
Non-editable sort of.
Right. So, good thing about these relational databases, as I kind of touched on earlier, they can store much more data than just a simple spreadsheet. Because you can imagine that you just have one giant spreadsheet with all the information on every order that an e-commerce site does. That's gonna be massive, that's gonna be a pain to manage. Whereas if you just break it into a bunch of smaller tables that relate to one another, the sum of the size of those tables will be smaller than the table that we were looking at earlier. So it just basically makes data storage more efficient. Right. And makes it easier to manage. Also, it means that things aren't all in one place for somebody to steal.
The basic purpose of the BigQuery is like if I see the queries are very similar to what we write in SQL, right? I mean, we use we have downloaded the SQL software.
Yeah.
The primary purpose of this is what? The BigQuery?
Yeah, so BigQuery is a cloud database environment. And basically, that means it can store more data and not rely nearly as much on your computer's processing power and just rely on what exists in the cloud and what it can dedicate. And yes, it stores data just like a Microsoft SQL Server database would, except this is just in the cloud. It's an environment that some businesses use to store their data because it can store a lot of it. And it takes away some of the resources from your own corporation.
So, like as a student, like I can use either Microsoft SQL or this, either. Like for example, how I do in SQL, I have my, the whole database. Imagine it has 200,000 records. I first take that file and then I extract queries out of that particular table, right? Here also I have a provision to upload the table.
No, unless you have a actual corporate BigQuery account, you're not going to be able to do that.
Okay.
But in BigQuery Sandbox, which is what we have been using, you can access the data that Google has put on there for community reference.
Okay, so where can I see the list of tables? Various tables, where are they available?
Yeah, I used to know how to get to that, but I couldn't figure it out earlier, which is why I haven't actually shown you the.
The sandbox is like just a learning environment, right?
Yeah, basically.
Right, okay,
Basically.
student.
One annoying thing about
Actual, like Sandbox is the learning environment, just to add on to what he has said. So the actual BigQuery is used by corporates, is it? Like because that must be a paid version.
exactly.
So
Yeah,
a
as will
corporate has
Snowflake.
an option, instead of purchasing a Microsoft SQL, I can just have a paid version of, the Google BigQuery. Is that what it is, the purpose?
Okay,
You can pay for BigQuery, but I would not recommend it. I would not recommend it.
bring your checkbook.
It's gonna be a lot more expensive and you already have the software. There's no reason.
No, I'm just trying to understand the primary purpose of the Google BigQuery.
Yeah.
Because Google as a company is very aggressive. It has come out with this product, same BigQuery. Now we already have the Microsoft SQL, which majority of the people use or even companies use.
I would not say that that's the majority.
We use, Microsoft SQL for our
I
data.
would not say that that's so much learning.
When you get hired by a big company and they're using this, you can learn how to do it in a sandbox and then get a job. Thank you,
Okay.
right?
Right, but I'm still not convinced with the purpose of Google BigQuery. What will it do? It's basically a learning environment, or it's like a competitor for the Microsoft SQL.
So BigQuery's sandbox is a learning environment.
Yes.
BigQuery as a product is a database environment that companies can take advantage of. They can upload their data to it and have that act as a database for them.
So it's like a competitor for the Microsoft SQL.
Exactly.
Yes,
Okay,
it's
got
just
it.
that it happens to be uploading your data into a cloud environment instead of onto a local server, like
Yes,
with SQL or Microsoft SQL like that.
okay.
Yeah, and I mean, there are other cloud database platforms, like the company I work for right now uses Natera, I'm sorry, that's the company I work for. The database provider that they use is Snowflake. And it's similar to this, it's cloud and everything, but as I kind of touched on earlier, the syntax can differ a bit, the names of functions can differ a bit, but the general structure is usually the same.
And this will support any kind of SQL, like I was searching on ChatGPT, it says there is TSQL, there is the Microsoft SQL, there are different types of SQL.
Yeah.
So each has its own, what do you say, slightly different syntax from each other. It supports all of
right.
that?
Exactly. Like you saw earlier, now we had to use backticks to add a name, to add a space into a column name. Some will require you to use a square bracket instead. Others will require you to use double quotation marks. But it's usually nothing beyond that. It's usually very minor syntax differences.
And when would you take advanced class of the SQL?
Did I take an advanced class?
Yeah.
No. I just did data warehousing and DBMS like you. And of course, I had to use
For
it.
me, as a data analytics students, we have finished this in the class, you're aware of it. So little advanced, it would help people like me.
I mean,
Or if there's any
Probably the
recommended
only
version
thing
you
that
want to put on your online data analytics club link, that would be good.
yeah. I think it's about time to stop.